In this video, we're going to do problem number 1 from chapter 10. So let me read that problem to you. So problem 1 says, to help your restaurant marketing campaign target the right age levels, you will want to find out if there's a statistically significant difference on the average between the age of your customers and the age of the general population in the town, which is 43.1 years. So part A says identify the null and research hypothesis. We ought to do that before we look at the data. We don't want to do any data snooping. So in order to do that, we first need to identify the parameter. So let mu equal the true mean age of our customers. Oops. Right, so this isn't the mean age of the population, of the city, that is, which we know from the census. Mu is the true mean age of our customers. The null hypothesis then is that our customers are no different than the typical person in the population, which has a mean of who has a mean of 43.1 years. The alternative is that mu does not equal 43.1. Now the not equal comes out from the statement of the problem. So let me reread this. You want to find out if there's a statistically significant difference. So that word difference is an indication that we don't care if our customers are older or younger. We don't, we just want to know if it's different. Therefore, we're going to use a not equal sign. Having stated the null and alternative, we're now allowed to go look at the data. So we do a random sample of 50 customers. So we have an N of 50. This random sample shows an average age of 33.6. So since this is coming from the sample, that makes it an X bar. 33.6, kind of looks like our customers are younger. And the standard deviation is 16.2 years. So S sub X, if you want, is 16.2. Now, always find the standard error. Just reflexively go find the standard error. So S sub X bar is going to be 16.2 divided by root 50. And if you do your math, this is equal to 2.291, carrying it to 4 accurate digits. Now, when we do a hypothesis test, we always start by assuming H naught is true. So if H naught is true, then the sampling distribution is going to be centered at the mean, which is 43.1, the population mean. Okay, so here's the sampling distribution of the mean, and due to the fact that we've assumed H naught is true, the mean of that is going to be 43.1. Now, when we do hypothesis testing, we want to evaluate how strong the evidence is against the null. So, out here someplace is 33.6, and we want to evaluate the area in this tail. So, if the area in this tail is small, what that tells us is if this is the true mean, it's very unlikely that we would ever observe a sample mean like that. However, if the area in that tail is big, then our conclusion is 33.6 could have arisen from a sampling distribution with a mean of 43.1. So let's go find the area of that tail. What's the chance that we would draw a sample giving us a test statistic X bar less than 33.6? So again, that's that area right there. Not quite sure about the distribution of age, but that's okay. I've got the central limit theorem. So from the central limit theorem, I can say that this is going to be approximately equal to the chance of me having a Z less than 33.6 minus the mean, 43.1, divided by the standard deviation of X bar, which I estimate with the standard error, 2.291. And this quotient is minus 4.15. If you type in norm s dist, enter 4.15, what you'll find is 0.0002. So that's the area in this tail. That's not quite our p-value though. So remember, we've got a two-sided alternative. So the two-sided alternative is that we're going to consider that tail as well as a symmetrical one off in the other on the other side, 0.00002. So our p-value then is going to be 2 times 0.00002, which is about 0.00004. So part B asks, perform a two-sided test at the 5% significance level. Well, this is less than 5%, so we reject H naught. Conclude, our customers are younger than the general population. Question 2, by the way, says, so 10.2, might as well knock that one off as well, says on the previous problem use a 1% test, well 0.00004 is less than 1%, so reject. One more thing. We could also do this problem with the confidence interval approach. So the confidence interval approach says take 33.6 plus or minus 2 standard errors, so our 1.96 standard errors. So the standard error is 2.291, and let's go find that in Excel. So I actually have the numbers typed in here. If we take, what was it, 33.6, so 33.6 plus 1.96 times the standard error, we get the upper bound. Let's take 33.6 minus 1.96 times the standard error. So the confidence interval extends from 29.1 to 38.1. So this is equal to 29.1 to 38.1. Let me just make sure I did that right. Okay, now notice that the reference value 43 is not in there. So since 43.1 is not in that interval, that would indicate that we can reject mu equal to 43.1. It's just not very plausible. So on an exam, you'd get full credit for using the p-value approach down here, or by using the confidence interval approach, unless I explicitly ask you to find the p-value.